In today's video, I will be solving a problem based on conjugate beam method. Okay, so this is the question. I'll write down here. Find slope and deflection at free end by conjugate beam method. So this is the question. Okay, here 1 point load is there and the UDL of 10 kilonewton per meter of 2 meter. So this is the question where we have to find out the slope as well as deflection by using the conjugate beam method. So here the first step is to find the bending moment diagram. So to find the bending moment diagram, we have to solve, let it be A and B. Okay, and the first step number 1, okay, to find the bending moment diagram. So here first bending moment at B, it will be 0, and always remember to find the moment, it's the formula load into distance. So what is load here? At this point load is 15, and where this load is acting at B, and how much this load cover the distance, it's 0. So the value for this will be 0. Therefore BM, bending moment at B, is equal to 0. Now we have to find the bending moment at A. So now here load, bending moment at A, so this load, okay, minus 15 into how much distance is covered is 2 to reach A point, minus again the UDL is 10 into distance covered is 2. Now in case of the UDL, we have to convert this UDL into a point load. So into a point load, that means we have to multiply it by half into the L. L is nothing but 2. Okay, just simplify it. This 2 and this 2 will get cancelled. Minus 15 into 30 is minus 30 minus 20. So then answer will be minus 15 kilonewton meter. Okay, so now we have a value for bending moment at B and A. Okay, so it's 0, so it will be like this, and at A is minus 50, right? So it's a UDL load, so the shape will be parabolic like this. Okay, so it's a negative. Now this is bending moment diagram. So again we have to draw the M by EI diagram. So M by EI diagram will be same as BMD diagram, and in my previous video also I have already mentioned about this, the M by EI diagram. Just only the thing is we have to divide the value with EI, so it will be 50 by EI. Okay, it's also negative. So this is M by EI diagram. Suppose and here this EI is equal to its constant. Okay, and suppose in question the value of EI is given, then we have to divide with this term, and whatever will get the value, we have to write this part. Okay, so in this question EI value is not given, so we'll take it as a constant term. Now the next step is to draw the conjugate beam, and we have some rule in case of the conjugate beam. So suppose in case of conjugate beam, suppose it's a cantilever beam and this side is fixed. So in case of the conjugate beam, what happened, the fix will be at this side. Okay, so this is the difference, and the bending moment diagram will be same as before. And here now see, this is A and this is B, and our values are negative, right? Negative means our force, this will act upward. If it's positive, then this force will act downward. Okay, so it's a conjugate beam. Then it will be minus 50 by EI is minus. Now step number 2 is we have already drawn the M by EI diagram, and step number 3 was to draw the conjugate beam. Now we have to find the slope at B. So slope at B, see, in case of the fixed support, the slope will always be 0, as I have already mentioned. Okay, in case of the fixed beam, the slope will always be 0. Okay, so here slope at A will be 0, and so we have to find for the slope at B. So slope at B will write like this: slope at B minus slope at A is equal to area of, this is a formula, okay, M by EI diagram. So this is the formula to find the slope. Now here slope at B, something will be there, but in case of slope A, as it is fixed, slope will be 0. So minus 0 is equal to area of M by EI diagram, this area. Okay, so we know that this is the shape of the bending moment diagram, so M by EI diagram. So to find the area, we have a formula that is 1 by 3 into H into B. So now 1 by 3 into what is H? This value is 50, minus 50, right? Minus 50 into the distance. Distance is 2 meter. So it's 2. So after simplifying, what value will get? Minus 33.33 by EI. Done. So this is the slope at B is equal to minus 33.33 by EI. Now next is to find the deflection. To find the deflection at B. So here we have a formula that is deflection, symbolize this, B is equal to moment of M by EI diagram at B. So here moment is equal to area into CG distance. So here area will be, this was the shape of M by EI diagram, right? So it will be 1 by 3 of H into B into the CG distance. This was A and B. Here the CG will act at the center, and from here to here it's 4 by 3 of L, and from here is 1 by 4 of L. It was like that, right? So no, it was 3 by 4 of L. So now the CG distance from this to this will be 3 by 4 of L. So here 1 by 3 into H is minus 50 into B is 2 into 3 by 4 of 2. So after simplifying, we'll get the value is minus 50 EI kilo Newton meter. So here the deflection at B is equal to minus 50 by EI kilo Newton meter. So now I'll draw the elastic curve diagram here. Okay, so our question was like this. Here UDL was acting, and that the last one point load was acting. Point load of how much? It was 15 kilonewton and a UDL of 10 kilonewton per meter and 2 meter. And this was our question. So our elastic curve will be like this, right? A, B, and it will be like this. So here deflection will form at B, theta B, and here theta A, slope at A will be 0, and our slope at B is equal to B. So we have already got our values. Slope at B is equal to minus 50 by EI, and our deflection at B is minus 50, and slope slope is minus 33.33. Minus 33.33 by EI. Okay, so this is our elastic curve. Elastic curve. Okay, so in my next video again I'll solve a problem based on conjugate beam. Okay, thank you.